And now, back to the weather classroom.
Okay, so now we know that the first step to becoming sky aware is just taking the time to look up, to check out the show that goes on over our heads every day. But once you start looking, what kind of incredible things will you see? Well, there's 3 different types of phenomenon or sky occurrences that happen in the atmosphere. They're optical, wind, and electrical. So let's hook back up with our weather diva Jocelyn, who's going to take us backstage at the Sky Show.
Optical. It means anything having to do with light and vision. So optical phenomena is all about when the light interacts with the atmosphere to play tricks on your eyes. It's kind of like weather special effects. Now normally the light travels in straight lines, but when it hits something more dense like water or ice in the air, the light can get bent. So the white light then separates and it becomes the most amazing colors. But the weird thing is, the air doesn't have any color. It's what's happening to the light as it goes through the air. For instance, we see the color in rainbows because of refraction. Now, don't worry if you don't know about refraction or any of that stuff yet. My personal assistant, Sarah, is with a big fan of mine, Dr. Ed Finkel, at the Fernbank Science Center in Atlanta, and they're going to show us how it all happens.
Personal assistant? I don't think so. Back here on planet Earth, we're with Dr. Ed Finkel. Hey, Dr. Ed.
Hey, Sarah.
Okay, so let's get to the bottom of this whole optical phenomena thing.
Okay, the first optical phenomenon I have to show you is refraction. Refraction is what happens when light goes from one material into another and changes direction. Here's a flashlight. It's shining down from air into water, and you can see that the beam of light changes direction. It's actually bending downward. So that's refraction.
Okay, cool. I understand that light bends, but what does that have to do with rainbows, and how do you get the colors?
Okay. To show you that, we'll come over here to this demonstration. Here's a very bright light source, and it's shining a beam of light. You can see that it's white. But over here, part of a beam of light goes through this prism, and when it goes through the prism, it bends. And it bends into these different colors. These colors are all there in the white light, but the blue bends the most and the red bends the least, and so you can actually see the component colors of white light now.
So do you always see these colors in a rainbow?
Yep, those are the colors that are present in white light.
Okay, now what does a rainbow have to actually do with rain?
Okay, well, over here we have a third demonstration. When it rains, the air is full of raindrops and little water droplets, and those are perfectly round and circular, not shaped like a teardrop. And they act like little mirrors. So right here, this laser represents the sun, and here's a beam of light hitting a raindrop. This beaker full of water is the raindrop. The light goes through and refracts here and breaks into its colors, and then bounces off the back surface and reflects off back into your eye. So if you're standing over here, opposite the sun, you will see all the beautiful colors of the rainbow.
All right, great, thank you. There you have it, optical phenomena made simple. Now, back to Planet Jocelyn.
What did she say? Anyway, of all optical phenomena, rainbows are the real prima donnas. Well, they're like me, dazzling and exotic. Now, early civilizations were so amazed by them that they attached religious importance to these beautiful weather shows. And in ancient India, rainbows were linked to the warlike sky god, Indra. Now, since rainbows are made when raindrops and light meet, you usually can catch one during showery weather. But the trick is, you have to be between the sun and the shower before the conditions are right. And the larger the raindrops, the brighter the rainbow.
Now, rainbows aren't the only glamour queens on the Sky Show stage. Let's check in with our favorite Sky Show critics. They're going to fill us in on the other leading ladies. This is Colin Marquis. He's one of the experts here at the Weather Channel.
Hey, Sarah.
Hi, Colin. So hopefully you can clear something up for us. What's the difference between a rainbow and a halo?
It's a great question, and they both appear as arcs of light or color in the sky, but they're pretty different. A halo forms as sunlight passes through ice crystal clouds, and the sunlight undergoes what's called refraction. And to see a halo, you would actually look toward the sun, whereas a rainbow happens when sunlight interacts with raindrops, and the sunlight undergoes 2 refractions and 1 reflection, but to see a rainbow, you would actually look in the opposite direction of the sun.
So how do you use a halo to predict the weather?
Well, actually, one of the more famous weather proverbs is a ring around the sun or moon means rain or snow soon, and that ring, of course, is a halo. The halo is caused by the high, thin ice crystal clouds, and those high, thin ice crystal clouds oftentimes will be the forerunner to stormy weather anywhere from several hours to a day into the future.
What other fun things go on in the sky that we might not know about?
Well, actually, I can think of two right offhand. First one is oftentimes called sundogs, and they are a cousin to the halo. When the sun is real low on the horizon, you can sometimes see one or two splotches of light or color on either side of the sun, and that would be called mock sun or sundogs. And the other one is iridescence, and that is related to coronas. Think of it as little bits and pieces of broken coronas playing off scattered clouds right in the vicinity of the sun.
Now, what makes a great sunrise or a great sunset?
Actually, Sarah, a lot of things can. In my experience, some of the most brilliant colors occur when the atmosphere is very clear conditions. Interestingly enough, man-made pollution such as hazes and smogs tend to wash out or mute those sunset colors, but also big volcanic eruptions or large forest fires, the ash and smoke from those can actually enhance sunsets over a large area, and sometimes under the right conditions you can see brilliant pinks, which would otherwise be quite unusual.
Cool. Thanks, Colin. That clears it up. I'll see you later.
All right, we've got to get out of here. Got some celestial celebrities we want to catch before the sun goes down. Hey, come on. Wait. We're out here in the Nevada desert to talk about the second type of sky show phenomena, wind. We all know what wind is, right? It's air in motion caused by temperature changes on our planet. It can be gentle and mild, or powerful and destructive. Sometimes it can be a total show-off. Check out this sensational windbag. It's a water spout. When a column of air starts to rotate fast over lakes and oceans, this guy appears.
Hi, I'm Horace, and I'm a dust devil. Sorry.
That's no dust devil. That's a dust devil. Dust devils are whirling windstorms. They resemble mini tornadoes, but they're nowhere near as damaging or intense. They usually happen in desert or dry environments and can be as small as a couple of feet high. Biggest ones get over 1,000 feet tall.
Wind makes some pretty sensational moving pictures, and when you combine it with glamorous optics, you've got a sky full of sensational color. But there's one member of the Sky Show cast we haven't met yet. So stick around because our high voltage gang is going to hook us up, and you better hang on because it's going to be electric.
The Weather Classroom will be right back.